In this video, I'm going to show you how to design a vibration isolator using the Mass Spring Vibratory Virtual Lab. If you have a single degree of freedom system where the forcing frequency is equal to the natural frequency, adding a secondary mass spring system so that K1 over M1 is equal to K2 over M2 will significantly reduce the vibration of the primary current. First, we will see the response of a single degree of freedom system being forced at its natural frequency. Click the blue title of the One Mass, One Spring module and double-click the corresponding box. Enter the system variables like mass and spring constant in the first tab. In the Force Response tab, make sure the Zero Initial Displacement box is checked and that Harmonic Force Response type is chosen. Use an appropriate force magnitude and enter the natural frequency of the system. For this example, we are using an amplitude of 2 newtons and the natural frequency is square root of 600 over 2. Make sure to click Apply at the bottom of the window, then click the Run Simulation button. This opens the Mechanics Explorer within MATLAB, which visualizes the system. After the simulation is finished, use the Open Scope Plot button to quickly view the position of the mass versus the simulation time. The simulation data is saved within the Out variable in the MATLAB workspace. Now we'll save the position data of the One Mass, One Spring system within the variable Simulation1 in the MATLAB workspace to compare to our vibration isolator system. To design a secondary mass spring system, click the blue title for the 2 mass, 2 spring module and double-click the now highlighted box. Make sure the variables for the primary system are correct and enter the values for the secondary system. Check the Zero Initial Displacement box and use the same force response variables from the single degree of freedom system. Click Apply and run the simulation. In the MATLAB command window, we now have the response data of both the single degree of freedom system and the 2 degree of freedom system. Compare the vibrations of the primary current from both systems. There is a significant reduction in the amplitude of the current's response. Using the Mass Spring Vibratory Virtual Lab and this process, you can design and compare many different systems.